Welcome everybody to the 2018 rendition of Intelligent Systems. We are going to be a team of, I think, at least 5 people. There might be someone else helping in one of the working groups. And that is Dalia and Dennis, who are going to give the working groups on the Thursdays and Fridays, and Jeffrey and Paul, who will be the practical assistants. Jeffrey and Paul are also the most important people in the past couple of weeks because they have re-implemented the game engine that we're going to do our projects on. So I hope it will be fine, but I'll talk about that in a minute. And I'm Stefan, so I'm going to give the lectures of this course and coordinate and help as much as I can. As you can see, I tried to do a recording of the lectures, and my plan is to just publish them somewhere as quickly as possible, hopefully today, so that you can re-watch it. But unfortunately, I cannot make any promises that you can keep that they will be online. So it's rather complicated, and for some other courses we have done it systematically. The people who have followed knowledge and data also know that I've used these video lectures instead of real lectures. In this course, this is not going to be the case. So you really need to know the lectures. And if we're lucky, then I will be able to put them online for your convenience, but chances that this might not be the case. So I want to start. I said it already, but I welcome you to this course. I hope we have 4 weeks of, I know, very intensive collaboration, but also that you enjoy it, that you learn things, and that I'll be able to enthuse you to learn more, to know more about intelligent systems and artificial intelligence. It's a very hot topic at the moment, of course, and this is sort of the introduction to systems that perform intelligently, which is part of the AI. So I want to start with something completely different. And that is also a question to you. Who of you have watched the series Person of Interest? So it's very funny because when I used this for the first time 4 years ago, almost half of the people had watched it, and now it's completely gone. So I show you how this works. I hope it starts. Yes.
You are being watched. The government has a secret system, a machine that spies on you every hour of every day. I know because I built it. I designed the machine to detect acts of terror, but it sees everything. Violent crimes involving ordinary people. People like you. Crimes the government considered irrelevant. They wouldn't act, so I decided I would. But I needed a partner. Someone with the skills to intervene. Hunted by the authorities. We would concede them. You will never find us. But victim or perpetrator, if your number's up, we'll find you.
So, I love this series, just to be, but I love American cheesy series, so you have to like it as well. The idea is that after 9/11, the US government requested a system that predicts acts of terror. An MIT-trained hacker developed such a system. It's an intelligent system, and he calls it the machine. It's a typing machine. This machine predicts acts of crime and classifies them into relevant and irrelevant cases. And then the main story is about the computer geek together with the superhero, and they rescue the right people, of course, in a very American style. So that's really cool. I like it. But it's also, I think, a very, very good way of thinking of intelligent systems and a good introduction to the theme of intelligent systems. So this machine is an intelligent system as you can find one. It has cameras and microphones as sensors. So It's a sort of the sensing side. And it has one actuator, one way of communicating with the rest of the world, and that is by placing one phone call and giving a social security number to the person who built the machine. And then it has, in principle, one main task, and that's classification. It says, this guy is in danger. Something needs to be done. And later, in the later stage, in the second series or so, the machine itself takes some actions and decides to act in the world. And what you see in the series is that many, many AI techniques are really used there. So we have text processing to analyze all the textured data that's around on the web. We have image processing to understand who's acting and who's not, what they are doing. We do data integration because you have to, all the sensor data from all the different sources. We have knowledge representation because there is explicit knowledge modeled, automatic reasoning, machine learning, genetic programming. So the machine starts coding itself. It starts writing code to improve its own behavior. These are really core themes of AI and of intelligent systems. And the whole approach is based on one assumption, and that's the assumption of rationality, that the machine tries to maximize the outcome for the expected outcome. So it tries to perform with a goal that it states. I want to help people, I want to recognize people, I want to classify, and it tries to give the best possible result of all the possibilities that it knows. So the question is it science fiction? And 5 years ago, this question was a bigger question because many of these things were not around. But nowadays, we have systems such as AlphaGo, where a human player really is outperformed by a machine. And for those of you who don't know, I will talk about it later and the next days, Go was considered even 5 years ago, 10 years ago, to be a game that it was impossible for a computer to play. And I think in 2016, AlphaGo really managed to play to win against the best Go player in the world. So that was a major achievement, and it basically is an incredibly complex decision-making process. Another thing that was considered impossible 10 years ago is a self-driving car. And now, of course, we all know that there are cars driving around American streets and maybe even also Dutch streets, driving, making the decisions on where to go, how to remain on the street, when to brake, and so forth. It's not a science fiction anymore. Some of you might use Siri, where you can really ask questions, natural language questions, and this is probably the best example of the sort of the knowledge that such a system can have. It's the Watson engine that managed to answer questions about any domain that you could ask, even including some reasoning and if given information that was not explicitly somewhere mentioned. So it's far beyond the search engine. So we are far closer to this machine than we might think. Yes?
You also have an AI that Elon Musk supported that played Dota real time and beat the best player.
Okay, so there are many other examples such as the one mentioned here. The point I want to make is that this is really real, and we are trying to build a system that not plays Go, but that plays a game as well in an intelligent way. That's sort of the practical task of this course. I have started to read Origin in the vacation, so I should have taken this maybe as an example. I don't know whether anybody has started to read this or read this book. It's a Dan Brown novel. It's typical Dan Brown again, but this is all about artificial intelligence. So if you want to sort of get in the mood of this course, you should start reading this. It's not deep, you don't learn much, but it discusses themes that are really relevant to this course. And in particular, also ethical questions, as you can imagine, because all of this is really, really, really about human beings, about intelligence, about us defining ourselves, about consciousness, and it really invokes very, very complicated philosophical questions and ethical questions. So can it be can it have a moral system? Can it decide what is right and what's wrong if it's not human? And if there is no human in the loop? What is consciousness? What does it mean for us to be aware of who we are, that we are, what we are? Is this something a machine can have, can learn? What is free will? Does a machine have the will to decide what to do? Or is it just executing what we taught it to do? These are deep philosophical questions that are related very much to what we're doing here. Can a machine be creative? Can it make jokes? And then the question is, if we are not allowed to kill a human, are we allowed to kill a machine that has the same intelligence? And I don't have answers to this, but I think it's worth taking a little bit of time in this course as well to think about these matters, and maybe in a bit more systematic way. They're ethical questions. Surveillance, privacy. We all have cameras everywhere. If a machine can all combine these things, is that something we want all the time? Do we always want to know where the other people are that we might trust or we might not trust? Of course, who's responsible if the intelligent car crashes into a wall? Is it, or into some people? Is it the person who built the car, or the person who bought the car, who drove it, who designed it? The algorithm? Can an algorithm be responsible? So there are many, many questions that are very important with respect to this topic. So now I've spent about 10 minutes talking about all these splendid things that intelligent machines can do, driving, decision-making, and so forth. And then I tell you in an announcement, please look at the game Schnapsen. Schnapsen. Of all words, I will use Schnapsen a lot. So are there any Austrians in the room? No Austrians. Any Germans? Okay. So you know 66? Name? No? Okay. Anyway. So 66 is the German version of Schnapsen, but apparently they don't know it either. So it's a card game. And it's a quite nice card game. So I play it regularly with my daughter now, since I know that we're going to do it in this course. And it's really cool, because it's very short. It's easy to understand. It has a fixed set of rules, so we don't argue all the time what's right, what's wrong, because we know the rules. But it's incredibly complex, given that it has only 20 cards and 2 players. So we both have 5 cards in our hands, and then we start playing, and it's really, really difficult to come up with a good strategy to win the game. It's very nice as an example for intelligent systems because it's deterministic and stochastic, so we know at each step what happens in the next round, but there is still an element of chance. And this is typically something that in many of the applications areas of AI you really want. And then it's multi-agent, because we have systems that just perform their task, but then we also have systems that perform tasks when there are other agents around. And that can be human agents, that can be other agents. So if you drive the car, there might be other cars. If you play Go, you have an adversary. And this is the same in Schnapsen. We have an adversary who tries to play as well as possible and who tries to beat me. So in a way, it's a very simplified version of an environment in which we want an AI to function. And that's why we've chosen for this game. And I will talk a lot about this game later today a little bit, but also tomorrow particularly and on Wednesday, because it has very, very nice properties for this course. So let's see. So now this first lecture will be a bit, how to say, I use a Kahoot, I use a I want to get a bit of feedback. I'm not going to do this every lecture, unless you tell me I should. So, but it's quite nice to do sometimes. So can you do me the favor, get out your phone or a computer, whatever works for you. Go to kahoot.it and then type in this code. sorry, I switched to me. So. So I will use the same quiz for more serious questions later. So please stay logged in if possible. You don't get any coins or this. So for the most crazy name, it doesn't really matter. Unless you win, or you score very well, and then you get with Schnaps and Netty, whatever. Doesn't matter. So anybody is still waiting to get in? Or shall we move on? Okay, I think we're done. No, lemonade is still there. Okay, I'm going to start. There was one more to come. Too late. Okay, there will be 6 questions, 1 starting now. Did you prepare for the course by learning Schnapsen? Yes, I looked at it. I mastered the rules. No time to learn the game. I could not be bothered to read the announcement. Answer now. Thank you. Okay. Oh, you're slow people. But I've given you more time. This is the one, sorry. So I should start with this. Sorry. I should have started earlier. I should have started with this. This is an incredibly intense course because we only have 1 month. So we have to do everything incredibly fast. Yeah? So I only gave you 10 seconds to do this because we don't have the time. But you have to really invest time in this course to be serious. It doesn't really matter. Anyway, the next one you have more time. But I just wanted to have an overview. Who are the 3 masters? Excellent. Excellent. You're my friends. Very good. Good game. Okay. To be honest with you, I don't. Yep. Okay, so there will be more questions in a minute. Okay. So this is the main question that you might have, and that is, I talked about intelligent systems such as AlphaGo. Winston is the intelligent agent that is the main character in the origin book from Dan Brown, I forgot to mention. So he's really clever, and I talk about the problem of Schnapsen. Are you joking? Yeah. So the point is that a game environment is often very, very good at testing methodology and at showing how good your technology works.
Schnapsen is probably kind of like poker in that it's a game of incomplete knowledge, right?
It is a game of incomplete knowledge, so it is a very suitable game for the kind of problems we want to address. And so that's why we spend a lot of time with Schnapsen. But the main thing is that all the technology and all the methods and all the techniques that you learn in this course that relate in this course to Schnapsen will be easily applicable on generic problems. And that goes from natural language processing, where you have to search for the right interpretation of words, to even image recognition, where the techniques are used, and so forth. So even if you hate playing card games, bear with me, accept it, that this is a tool to learn things that are really, really, really useful. And it's no coincidence that Google decided to invest millions into winning against the Go champion, because it's a very, very good showcase, and it's very good to understand technology. And so we do the same in our little world with Schnapsen. So what are the core topics that I'm going to address in these 4 weeks of this course? The first one is related to this point I made in the beginning. The intelligent systems, the machine, tries to optimize its behavior according to some goals that it sets itself. The principle of rationality. And what that implies is that if we make some kind of abstract representation of the world that describes very well the problem space, then we can apply generic technology of search to find solutions. And if you think of an example such as chess, then if you think about it, already in 5 moves, for example, you have so many different options that you can't apply a brute force algorithm anymore. So you need very, very specific heuristics, ideas of how can we guide the search through this space. So how can we find the one position which gives me the advantage over my opponent to win this game. So the 3 elements that we're going to look into here is state spaces. How can we represent a problem in a complex world in an abstract way so that we can apply simple or complicated or at least we can apply systematically some search procedures. And the heuristics are the human knowledge about the games and the environment that help us find the right solutions as quickly as we can, or find them in the first place, which is already difficult enough in many cases. The second element of intelligence, in my view, is knowledge. So things that either we humans have learned and built as sources explicitly, and I've spent 2 months of your time talking about knowledge in the course Knowledge of Data for the LI and LE and EMM students. So knowledge is, I think, a core element of intelligence. And if I talk about knowledge, there's many things. So we have very explicit classification schemes like the Linnaeus classification scheme of species. We have networks of people and how people are related in these networks. We have more structural information such as PageRank, so what is the most popular node in a network. But we also have the sort of very formalized specific knowledge such as the mathematics, the mathematical formula, and so forth. And as you can imagine, in the time of the web, this information is huge. And it helps us very quickly to get to very good information. So Siri builds on this web structure to find explicit knowledge and to reason with this, but it also creates an incredible problem. The amount of information and the amount of data that's around is very, very difficult to handle. So this is a sort of a balance between how much knowledge can we use and what can we do with this in practice. And the last element of intelligence, in my view, is, and I think it's recognized as machine learning. It's the adaptivity that an intelligent system learns from what it does, from the world, what the world does, and that it doesn't make the same mistakes again and again and again. And we can think of machine learning again, or learning in general, in very different ways. We can think of recognizing a bird that we've never seen before, but we still know that it's a bird because we see that it has wings, that it has 2 legs, that it has a beak, whatever it's called. We can have very explicit knowledge representation structures that we learn. So this is a decision tree. It's a very classic form of machine learning, where you classify diagnoses, where you say, okay, if you go to the doctor, the first question he asks is there a tachycardia, which is a heart condition. So they classify you according to risk groups, for example. And usually these things are learned from evidence. And we, obviously everybody uses every day the spam filters to help with the mail that would otherwise clutter your boxes. So what is the expectation for this course? At the end of this course, you will have some basic insights in information systems and AI. So I explicitly say basic insights because AI is obviously a huge field, very complex. What you will have seen in the basic forms is how to represent problems as state space problems, state space representations, how to apply basic search strategies, that's what we're going today, and advanced search, informed search, how agents in complex environments behave and what sort of properties they must have, and so forth. We will see some knowledge-based reasoning. So how can an agent derive facts that are not explicitly stated by some logical applying some reasoning algorithms, automated reasoning, and you will see some machine learning techniques, a bit of neural networks and deep learning. Just the basic idea, you will get more in-depth machine learning next year, but so that you get some basic ideas and that you can use some of the machine learning tools that are around now. There are many topics related to intelligent systems that we're not covering here. So we're not talking about planning, we're not talking about natural language processing, robotics, vision, perception, and so forth. But I think these are recognized to be some of the most core important parts of intelligent systems that you should have seen in your study. Then we really want you to apply the things that you learn, the techniques and the theory that you learn in a practical problem. So that's why there will be a practical assignment which really decides on most of the mark, the final mark, implementing an intelligent system that plays the game of Schnapsen, as you have already guessed. So all of you should implement several game-playing bots during these 4 weeks. And then, explicitly, I also want you to really experience doing some kind of research. So it's an explicit goal that you come up with a hypothesis, a research question, and that you write a research paper about it. So how are we going to do this with our Schnapsen game? We represent the game as a state space problem. We search for optimal solutions, which are then the moves that we can make. We study the multi-agent behavior. So in other words, we have an opponent that we have to take care of. And then we represent the strategies as logical rules. And finally, in the third week, we're going to learn strategies automatically using some existing machine learning tools. So basically what Google did for Go, we do for Schnapsen. And it's a bit easier, but it's not so much easier as you might think. But we get to that later. So one more thing you're probably interested in is, okay, intelligent systems, nice and well, but I want now I lost my sentence, so I have to try again, sorry. So intelligent systems, nice and aardig, I wanted to say, but how do I get my credits? That's the only thing that I really want to know. Yeah, so I should spend some time on how do you get the credits for this course. And basically there are some learning objectives that we have per week. So at the end of the first week, you should understand the basic concepts of agents, state space representation, and heuristic search, and the min-max algorithm without beta pruning. And the min-max algorithm is basically the algorithm which tells you in a game with an opponent which move you should take based on the assumption that the best move that the opponent could make. And then alpha beta pruning is just for efficiency, it's a way of making the min-max algorithm scale a little bit more because it's very expensive. And what you also should do in the first week is to implement an intelligent agent, which is a game bot, which can play Schnapsen, at least part of Schnapsen, with min-max and the heuristics. And when I say part of Schnapsen, for those who looked at the rules, there are two phases in the game of Schnapsen. You have one where the cards are refilled, you get new cards from the pile, and there is one phase where you just play the cards out of your hands and there's no more information coming. And basically the second phase is a perfect information game. So it's a relatively simple game, the second half, and this is where you can already implement these algorithms for the second phase. How are we going to do this? I'm going to give 4 lectures. Every day at 11 o'clock, I'll be here talking to whoever comes. There will be one working group for each of you. And if you haven't registered yet, do so. And Daya and Denise will really go through step by step through the algorithms, things that you might not understand here, you can discuss with them. There will be exercises that have already been published on Canvas that you go through so that at the end you really understand in more detail, in a bit more practice, what I tried to explain here to you in a plenary session setting. And then Geoffrey and Paul will be available to help you with the programming. So they wrote the code, they know exactly what it is. And so I've prepared some sheets where you can pin in times where you want to talk to them, and they will help you with the technical problems. But the hope is that you can really do this without practical sessions. In the second week, we move to the topic of knowledge. So we use some logical formalism to represent the strategies of the game, and then reason over those to derive implicit information. We will also talk about basic concepts of uncertainty and vagueness, so probability theory and fuzziness, and implement those in the intelligent agents again. How are we going to do it? We have 4 lectures again, 1 working group, program if you need, and at the end of the second week, I will publish a practice exam, a test exam, a digital exam, so that you get some idea of where you stand and whether you understand enough to pass the exam. In the third week, we move to learning, and then you will really understand, hopefully, the basic concepts of machine learning, how to train a neural network, how to train a model of deep learning, sort of the basic ideas of it. I don't want to promise more. And then I also want to spend some time on how do you write an AI research paper. Many of you have already had courses of how to write a paper, but I want to spend a little bit of time to give you some guidance. And I also want to spend time on the ethical and philosophical questions. And what you have to do at the end of the third week is to implement an adaptive intelligent agent, so one that learns from its own games, from other people's games, and so forth. There will be no, I call them milestones in Canvas, but there's nothing you need to hand in. It's just a recommendation that by the time of the end of the week, you should be more or less at this stage. Yeah, and if you follow these milestones, then you should be well on the way to write a good research paper at the end. Again, in week 3, we have 4 lectures. Monday, Tuesday, Wednesday, and then I will give a recap on Thursday. So basically, I will, in a plenary session, go through the exam of last year and explain what was difficult, what wasn't, and so forth. And again, there will be a practice theory working group and a programming help. And in the final week, there will be no more lectures, but you will have to pass an exam on the Monday of the third week. So there are really 3 weeks only for understanding a lot of material. So you really need to get started very, very early. That's the price for these short periods. I like it a lot because in a way tomorrow I can continue the story that I'm telling today and nobody has forgotten, or at least I haven't forgotten. So that's very nice, but I also know that it's an enormous pressure on you because you really have to perform 3 weeks, you have to process a lot of new material, and that can be very hard. So please do me the favor and start very early, because this course really is meant to be a full-time course, and that means 40 hours a week is really what is expected. And if you don't put that in, you will be in trouble. So maybe I just the anecdote. Last year, I got the evaluation of this course back, where people said it's far too much work. It's far too hard. And on the same page, the students said that only 20% had put in more than 24 hours. So 80% of the students last year thought that they had worked less than around part-time, but thought the course was too hard. there's very little I can do about this. So please, 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 take your time, take the reader out today, start reading, start looking at the video material that is provided, and so forth. It really is meant to be a full-time course. At the end of the 4th week, after the exam, you will have implemented the bots, and then you have to write a research paper that explains the behavior of these bots. So why does the one perform better than the other? And then you have to write a research paper about it. The report has to be in on Thursday night, and it is a strict deadline because we have the Friday to write peer reviews. And that is really something very important. We are going to use the Easy Chair reviewing system, which is the professional conference organization software that we use for our conferences. So I'm really running this process in the same way as I would run a conference. And that might make it, at some points, makes it more difficult to deal with rather than using Canvas for peer review, for example. But what you get is exactly what you will get when you submit your first paper to a conference. And when you are invited to be a reviewer to a first conference, you will have used probably exactly this system. So that gives you some idea of how it works to do research in AI, also from the more technical side. So how to pass the course? You have an exam which counts for 30% of the final mark. That's not that much, but you need to pass it. That's the big thing. It's a barrier. You will have to apply the basic algorithms that I will try to explain in the lectures for the first 3 weeks, and then practice in the practical sessions. You will have to present a problem as a state space, solve it through search. You have to present a problem logic and reason with it. You have to train and apply a learning algorithm. You need a little bit of the mathematics behind these learning algorithms. And then you have to understand, give some understanding answers. Even though it's a digital exam, you might have to type some answers, or you might have to think of the answers more carefully. And there will be also a small part will be on the philosophical and the ethical impact and problems around AI. It will be a digital exam, and I will also give you a practice exam with questions from last year so that you know more or less what this is going to be. So that counts for 30%, but you have to pass it. The bigger part is the research paper that you are about to write, and that means you have to implement 3 bots, one a standard min-max, an adaptive and a knowledge-based game engine intelligence systems. You have to describe this, the implementation in an appendix, and then you have to write a scientific paper that sort of outlines a research question. Is there any indication why this bot works better than another bot, and so forth? Or if I search deeper, my game results will be better. And you have to write a scientific paper about this, which will be then evaluated by your colleagues in peer reviews and by me in a meta review. And the Schnapsen will be our sort of playing environment, the thing that we're going to implement our bots on. You have to implement the bots min-max alpha beta, but they are more or less given in the system. Perfect information Monte Carlo sampling is also almost given in the implementation that you will get tomorrow morning. You will have to write a knowledge-intensive bot, an adaptive bot, and then the question is comparing those, writing research questions about it, and review the other papers, and then we are done. So, advice on how to pass this course, please check the announcements on Canvas. I try to reduce them to a minimal amount, so I don't want to push too many of them. But if I write some, please take the effort to read it. I sent an announcement 2 days ago, I think, on what happens to people who have passed a partial result. You cannot imagine how many questions I still get from people who have had a partial result, is my practical result still valid? So, and we have 250 people registered in the course. If 10% of you do not read the announcements, I get emails from 25 people about things that I have already stated. Please, please, read the announcements. Register on Canvas. You should register with the working groups as soon as you can, and also with the research groups. In groups of 3, I know there's always problems with do we do research in groups. Some people like it, some people don't like it, but it's the only thing that scales with 250 people. And it is also a very, very good thing to do research, because research is a social activity. Nobody in our field, nobody at our times does research on their own anymore. So it is important that you learn to collaborate with other people. So try to find people you trust if possible, and then collaborate with them in 3. You have to take and pass the digital exam, and that's on Monday in the week 4. You have to hand in a good research report. And Thursday of the week 4, you have to provide 2 peer reviews, and we use the real system for conference organization. And I hope that you really enjoy it and that you really try to understand and get more out of the course than just the 6 ECs.